When we evaluate a trigonometric function, the input is an angle, either in a radian or degree, and then the output is a numerical value. It's the ratio of side lengths, like the opposite over the hypotenuse lengths if we're doing sine. So inverse trigonometric functions. Inverse functions are when we, quote unquote, swap the x and y. So now for inverse trig functions, the input is the numerical value. It's the ratio of the side lengths, adjacent over hypotenuse, for example, for cosine. And then the output is an angle. As we saw with the unit circle, though, there are as many angles that have the same output for each trigonometric function. So one of the more challenging things to remember is when we evaluate inverse trig functions is that we restrict the range, or we restrict the output values. For inverse sine, which can be written as sine to the negative 1x, or inverse sine, that's how you say that, or arc sine, our outputs are going to be angles between, and you can see it right here, between negative pi over 2, which is, again, that angle, all the way to positive pi over 2. Again, we're not thinking about degrees here. For cosine, your answers must be between 0 and pi. So here is 0 radians, here's pi radians. Again, so this is inverse cosine or arc cosine. And then lastly, for inverse tangent, it's the same as inverse sine. So your output angle must be between negative pi over 2 and positive pi over 2. I'll just demonstrate to make sure that's understandable. So the first one, inverse sine of square root of 3 over 2. The answer here is, if I draw my unit circle, we know right up here at this pi over 3, the ordered pair is 1/2 comma square root of 3 over 2. And again, we know inverse sine is y, or sine is y. So this angle is pi over 3. Now you might be saying, well, if I go right here to 2 pi over 3, this is the ordered pair negative 1/2 square root of 3 over 2. So why can't I not say 2 pi over 3? Well, it is true that the sine of 2 pi over 3 is the positive square root of 3 over 2. However, as mathematicians, we restrict the domains. And so you just need to know those range restrictions, to be able to answer it correctly. So the next one here, inverse cosine of negative 1. So this is asking, again, I'll just present this in a different way. The cosine of what angle is negative 1? Well, cosine is equal to negative 1 right here, because remember the cosine is the x value. So that is the angle of pi. But you could say, well, negative pi also gets you there, or 3 pi gets you there. Yes, they do. But again, we must answer within the specified range. The inverse sine of negative 1/2. So I know, again, my answer needs to be either in quadrant 1 or quadrant 4. It must be in quadrant 4 because this is a negative value and sine or y values. So I know I'm down here, and if I remember my unit circle, this is the ordered pair square root of 3 over 2 negative 1/2. So sure enough, this is negative pi over 6. We don't want to say 11 pi over 6, even though that ends at the same spot. Again, we don't want to say that one, the one I'm writing and now crossing out, because our answer needs to be between negative pi over 2 and positive pi over 2. The inverse sine of square root of 2 over 2, cosine is positive in this quadrant, and it's at the pi over 4 angle, so I'm going a little bit faster there. And then just a few more before we wrap up. The inverse tangent of 1. So again, tangent is answered in either quadrant 1 or 4. It must be in quadrant 1 because tangent is negative in quadrant 4. And tangent is equal to 1. So again, I'm thinking tangent of what is equal to 1 at pi over 4, because both x and y are the square root of 2 over 2. Lastly, tangent of square root of 3 over 3. Again, I'm in quadrant 1 or 4, but because this is a positive ratio, I'm in quadrant 1. And so I'm between pi over 6, pi over 4, pi over 3. We just saw that pi over 4 is 1, so it won't be that. And so then I'm just going to write this ordered pair right here, square root of 3 over 2 and 1/2. So then if I do y divided by x, which is what tangent is, I get the 2's canceling out, 1 over the square root of 3. If I rationalize the denominator, sure enough, I get square root of 3 over 3. So we found the angle. The angle is this closest one, the reference angle of pi over 6. So this is pi over 6 degrees. Thanks for watching, everyone.